Hello everyone, in this video I would like to show how can we implement the TwinCAT 3 Ethernet IP scanner function in one actual Beckhoff controller. The controller what I'm using, that is C6030, that controller. That controller installed the Windows 10 system is actually running as a small computer. And in this case, I'm going to use this software-based TF6281. I'm using the built-in Ethernet card from this Beckhoff controller. We only use this software way. We do not need to purchase any hardware, additional hardware. Definitely, you need to purchase this software license, but this is a cost-effective way. For some data traffic that's not high enough, probably you can select this TF6281. If you definitely have a higher data traffic, the Ethernet IP communication traffic, then you can pick this EL6652. This is the one dedicated that hardware module. That's a scanner or the adapter terminal. It also have a 2-port here. From the configuration wise, these two ways almost the same. So that's why in this video, I will show using this TF6281 this way. Okay, let's shift to the TwinCAT 3 system and let's create a new project and let me show how can we implement that. And in this test, I'm going to use one more 8 input, 8 output module. That's the Ethernet IP remote device. Okay, now let's right click XAE, run as administrator, and select this location directory. In this case, I'm going to create this project under this directory, Ethernet IP TF6281. Okay, TwinCAT project EIP master. From the EIP word, usually called master or called scanner. Okay. All right, PLC. Let's create one PLC project. Select this standard PLC project. Make sure we are same location. So this PLC name, we can name that C6030. This is my controller. And EIP master. Okay. And before I switch to my controller, probably you can go to the TwinCAT icon and make sure the added router so you can connect one actual controller. Okay. Also, you can use your laptop, select the local here, using your laptop built-in Ethernet card to do this test. This is the same case, but in the actual case, you definitely will have one controller. Probably this is the Beckhoff controller. So this is the exact same case as my side. Okay, I'm using C6030, this controller. And cross here, that connected show cross, that means I'm connecting. It's available to connect this controller. So now I'm going to switch this controller. So here shows no arrow, that means I'm connecting this controller now. Okay, so I create this PLC. Now I can go to the I/O here and select these devices. If we are going to use TF6281, we have to manually configure something under these devices here. So from here, right click, click this add new item, and then go to Ethernet IP. And from here, we can see adapter, that is a slave, and scanner run as a master. This is the hardware solution, EL6652. Now I'm going to use the software way, so I'm going to select this Ethernet IP scanner only. There's no bracket, shows nothing. Okay, Ethernet IP scanner. And named device 1. Okay, click OK. We temporarily close that window, and then let's go to the system and click this license. So firstly, we need to make sure this license is turned on. So for testing purpose, we can activate that trial license. So now I'm connecting this external Beckhoff controller. So make sure this selection, the choose the target, that is your controller, your target controller. So once we configure this Ethernet IP scanner, this license will automatically show up here. So now I'm going to activate this license. Click this trial license. So type in. Okay, 7 days trial license. Okay, we can switch back and forth. Now it's activated. Okay, let's shift back. And now let's click this scan. Device should be reloaded before scanning. Okay, so let me firstly download this configuration. Click this active configuration. So this will download this configuration to my external controller. Okay, it asks us to link one variable. Okay, we will do this after. Okay, it shows runtime issue. So let's go to the runtime and let me read from the target. This actually read this target that come from my external controller. Now this controller has 4 courses. So it read that this. So 3 as a share, 1 is isolated. We need to select this isolated. Okay, here we assigned 1 isolated core. Okay, we can select this set target. Okay, this assign this real time. Assign which core of this controller we can run our project. Okay. And let me download again. Okay, it shows we need to connect one variable. We will do this after. And then let's double click this new added device. We can see a couple tags here. So firstly, let's shift to the adapter. So this area is very important. This is used to assign which Ethernet adapter will be used for this communication. And for example, in this case, I'm using the C6030. Inside this small computer, it actually has 4 Ethernet cards inside. So we need to select one of them. So now I'm connecting that the number 4 Ethernet card. I'm connecting this target system. If I click this search, it doesn't show anything here. That's because the controller what I'm using, the Ethernet cards inside this controller, inside this small computer, it doesn't have any driver inside. The driver named TwinCAT real-time driver. The driver includes EtherCAT, Ethernet IP, and PerfectNet, as well as other real-time communication driver. We need to install this real-time driver into our Ethernet card. So we need to shift to that controller. We need to install the driver at first. So please follow me. So I'm going to use the remote desktop, type in this IP address 1.10. And now, so double check that port I'm going to use as the Ethernet card, select the Ethernet. So inside this small computer, it has 4 Ethernet cards inside, but the name, they are quite similar. So I need to check out. I'm using this Ethernet card, it named Ethernet 4. We will install TwinCAT real-time driver on this Ethernet card. Because we install the TwinCAT 3 software, so I can open the TwinCAT 3 software. I'm using the remote desktop, and the software is showing up that's actually within external small computer. So without creating any project, we can go to the TwinCAT and click this Show Real-Time Ethernet Compatible Devices. And at here we can see this is that card I'm using, that Ethernet 4. So I need to click this install this real-time driver for this Ethernet card. So click this install. Okay, we install that. Then let's go to the Ethernet card list. So this is that card. So after it install the real-time driver, we can see the name showing here, a name TwinCAT Intel PCI Ethernet adapter. So if we double click, now this IP address I set 1.11 for this port. And after this, we can shift back to my engineering laptop. So make sure we are connecting this target system, this C6030. And at here, I can click this search. And after we install that driver, so the system will automatically show up the card installed this driver. So Ethernet 4. Okay, Click OK. So it also automatically pop up this IP address 1.11. Okay. So this is a very important step that assign which Ethernet card can be used as a Ethernet IP master. This is the hardware assignment. Okay. And then let's shift to the Ethernet IP. This area we can leave as a default. Go to the synchronize task. Here, some cases you might select this because this talk about the task at here. By default, we are using this PLC task, that's the 10 millisecond. For the synchronize, communication synchronize, some cases maybe you can create a new I/O task. That new I/O task can be faster than 10 milliseconds. And in this test purpose, I can select this standard or select this specific synchronized task. For example, I can select this PLC task. And then let's go to the setting. So here, this IP address is very important. This is the Ethernet IP master IP address. The IP address I set here 192.168.1.20. 1.20, this IP address is one virtual IP address. This virtual IP address will run as that Ethernet IP master. Make sure this IP address is not the same with other hardware Ethernet card. Take care of this. So I set this 1.20 and Ethernet mask. I set this. Okay, master info. So all those we can leave as a default. And now we can download. Click this active configuration. So build this solution first. And now it refreshed. So if we browse this F900, so before we set this 1.20 at 800, once we download active this configuration, so once we shift to this F900, and once we see this 1.20 showing here, that means this configuration from this 800 download into this controller, and this controller is running this controller. Okay. And we set up this master. Now we can connect the remote device. That remote device is an Ethernet IP device. So now we can browse, go here, and click this add new item, or we can import the EDS file. For my case, I have one EDS file ready, so I can click this import EDS file. So I can select this 56917. This is the MURR Impact 20, that 8 digital input, 8 digital output module. Okay, this is that EDS file. Open. Import successfully. And then we can click this add new item. After we install the EDS file, so this MURR Impact 20, 8 input, 8 output module will show up here. I can click yes. Okay, it show up here. If you don't have the EDS file, you can also manually add a new item. So this is a similar way as Allen Bradley compact logics when we add one generic Ethernet IP device. So you can click this generic Ethernet IP slave. Click OK. I would like to discuss this slightly after. Other than adding the EDS file, we can still browse the online connected Ethernet IP devices. To scan the Ethernet IP devices, switch this system to configuration mode. And then we can use scan function, active free run mode. Okay, and from here we can click the scan. So it will show up the devices it can search. Well, in my case, I connect this remote device, this impact 20 to this controller. So this controller actually can find out this device. And its IP address is 192.168.1.193. Okay, I can directly use this. Okay, I can remove this, manually edit. Okay, this is automatic connected. So once we go to this device, from this device here, we need to double check the IP address. Right click, we can select this change IP address. From here, if you need to change the IP address, you can change. For check this IP address, we can also come here to look at that. So in the actual case, this MURR device, its IP address is 1.193 because I searched that, I scanned this device, so definitely a match. Okay. Also from here, and then since this is 8-digit input, 8-digit output module, so from this input and output, we will assign the inputs and outputs under this device. Since we install the EDS file, so from here we can right click this load from EDS file. So this automatically loads the configuration from the EDS file. Successfully loaded. So it loads this EDS file configuration. And then we can go to here, right click this append IO connection, click this IO connection, and create a variable as defined from the EDS file. And since that EDS file, we install the EDS file, so this device has an 8-digit input, 8-digit output. So the first byte, that's the input, and this byte represents that 8-digit output. So we can see here that one input, one output here. This connection input output. Then to link the variable with the hardware, we need to create 2 bytes. One represent input, one represent output. Okay, so let's go to the GVL. Let's create global variable list. I will name that IO. And to declare 2 bytes, one for input, one for output, so we need to follow this syntax. For the digital input, that's the byte, okay? We need to follow this syntax, AT space %I star, and that's the byte, okay? And for the output, we can name that output byte more, AT %Q star. Okay, we declare those 2 bytes, one for input, one for output. And if now I go here, click this change link, so it doesn't show anything here because we haven't built this project yet. So this project haven't generated this tag behind. So let's build this solution. And now, if I switch to here, bytes, click this change link, or we can double click and click this link too. So now it show up. So this input only show the input variable we declared as an input, okay? And same thing for the output. So if we click this link too, it will only show the output and also show the byte style because the selection here, okay? We connect those links. And now if I download this project, download this active configuration, okay, and click this login, download the program. And now if I type in a data, for example, if we set 2, so we will see the output will turn on. Okay, now if I give the signal to the input, so we can see it shows 1, and second input, it will show 2. Third input, it will show 4, right? This is the integer style. And the fourth one, it will show 8. Okay. And also we can go to this area and we can go to online and see the actual value from this input. Okay, we can see this value. The third input, the fourth input, that's the 8, right? And you might have a question, how can we pick the individual bool from this byte? So we can program like this way. From this main, I'm going to use the digital input to directly control the digital output. For example, I can do this, IO dot the output byte MURR dot 0. 0, that's the first output. We can use the input directly control this output. So this is the input byte. To use the individual bit from this byte, we can use, for example, I can use this 2. Okay, using this way. Or if I use the declared one local tag, for example, the bool tag, I can declare one local tag. And this is one bool, right? I can use that the byte, the number 0 byte, directly control that. Tag can directly control by the 0 of this input. Okay, the very simple way we can log in. Okay, now if I turn on this dot 0, so we can see this dot 0 on. So we pick this individual bit from this byte. Okay, and if I turn on this number 3 input, that's the dot 2. So we can see this number 3 on, so it control the IO dot output bool this dot 0 to on. Meantime, my output, the number 1 output dot 0, it turn on. So if I go to this output, so we can see it turn on to 1. It control this byte. Okay, so this is a Ethernet IP slave. So now my controller running as an Ethernet IP scanner, and this Ethernet IP device, this impact 20, 8 digital input, 8 digital output, is running as a slave. So I connect this variable here, connect 1 byte and 1 byte here, so it's communicating. And this is the case we have the EDS file. If we quickly recall, so firstly I import EDS file, and then we switch to the configuration mode. And from here, we click this scan. Make sure we are under the configuration mode. Click this scan. So we can scan the devices. It can communicate with the Ethernet IP, right? No new, because I scanned this already. After we scan this device, right-click this device, we can click that load EDS file. So all those I/O can be loaded from the EDS file. So once you right-click, click this I/O connection, so the default, that variable, this area will be loaded from the EDS file to here. So the question next will be, if you have one device, it doesn't have an EDS file, how we can do that? So we can do this. So right-click, click this add new item, select this generic Ethernet IP slave. This is a similar case as the Allen Bradley compact logics or control logics. When you add that generic Ethernet IP slave device, you can select the generic file, right? And click OK. And at here, go to this setting, double click this station. And firstly, you need to set the IP address for this device manually, right? 21, for example. And then we need to manually assign that I/O assembling and configuration. So at here, we can right click. This time, we don't have the EDS file can be loaded. Now we can go to the appendix I/O connection. So we can select this without EDS. We can see this connection name is under this device, this generic device. So this area we can see, it shows that config instant number, config size, slot number, and the connection, this number here. And this data length here. So for example, the data length, you have a 10 byte need to communicate, and connection point. The cycle time multiplier that's used to set what the scan time from the master to the slave. For example, if the master scan, that cycle is 10 milliseconds. If we set 2 here, that represent 20 milliseconds. That is the cycle time from the Ethernet master to slave. So for instance, most of cases, this config instant, probably we can set 100, the assembly number, right? And this connection point, so sometimes for the input and output, some cases it can set 101, and the output we can set 102, right? For the robot or for other Ethernet IP slave. So this is the manual way to assign the Ethernet IP parameters. And after we configure here, since there's no length configuration here, so we can go to this IO here. For example, if we have a 8 byte we need to communicate, so we can click this byte. So we can name that byte input variable. And multiple, that's the length. For example, we have a 10 bytes. And this is start address, okay? And click OK. So we will declare 10 bytes here. And for the output, same thing. So click this new. And for the output, we can declare, for example, byte output variable. And this time we can declare 4. Okay, start, that depends on the mapping, that Ethernet IP slave mapping, right here. And then you can declare the variable, that's the byte or bool. So you can go to the variable, click this link to the variable you declare as an input and output. If you record from here, you need to follow this syntax. All right, this is the software way we implement the Ethernet IP master. So we use the trial license TF6281. This is software way that because from that controller, if we quickly record, if I use this remote desktop, I'm browsing this external Beckhoff computer. I open the TwinCAT 3 software without opening any project. We need to go to this TwinCAT, click this show real-time Ethernet, and pick the Ethernet card you are going to use as the Ethernet IP master. And now I'm using the Ethernet 4. I install this Intel PCI, this adapter driver. So this is the real-time communication driver. After we install this, so when we create this device here, so keep in mind, for the adapter, once we install that, when we click this search, make sure this connection target, we are connecting that target device. Once you click this search, it will search the available device. You must guarantee that card has been installed, that real-time driver. Okay, so using this way, we do not need any external hardware to implement Ethernet IP master. We use this software license. Definitely you need to purchase after, but for testing purpose, you can quickly verify. You can use this license, activate that, and set up this device here, and also import the EDS file or manually install this Ethernet IP slave. Do a quickly setup. All right, that's it for today. To use the software way to implement Ethernet IP master function in Beckhoff TwinCAT 3 system. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.